Welcome all. I am Parthivan Palanichami. I am going to give details about reaction turbines and comparison between impulsive and reaction turbines. Let's start. Impulse turbine already we have discussed in that previous part. Here also showing that the water is entering on the rotor blade, which is uh, against on the rotor blade. Because of that the rotor shaft will get torque. Through the torque it will started to rotate, and the bottom figure is showing that guided plate with the rotor blades, and the water is entering through the guided plate to reach the van blade. After reaching the rotor blade, it will be exit at another end. Here you can clearly see the steam velocity and pressure. As per the impulsive turbine, the steam velocity initially started from lower level and it is increasing in that peak at entrance of the van blade, and then the water started to exit. Automatically the steam velocity going to drop down. When the drop down the steam velocity, the steam pressure is maintaining at constant level. During the entry of the guided plate, the steam pressure will be dropped. After dropping, it is maintained at constant steam pressure. According the reaction turbines, here in the top figure showing that steam exit from the nozzle. The nozzle assembled on the rotary shaft. The rotary shaft inside will provide small hole to supply the steam at high pressure. In the high pressure steam trying to enter into the nozzle, and the nozzle leave or uh, allowed to exit the steam out. Because of the back pressure, the rotary shaft automatically started to rotate. In the torque transmitted into the rotor shaft to generate power through the generator. And then the bottom reaction turbine figure showing that guided plate and rotary blade figure, and the water entering look like the wave form. The water started to enter at the top portion of the guided plate, and then it is moving towards rotor blade, and then it is exiting at the right hand side. Because of that, the steam velocity is started to increase at the initial stage, and after entering the rotary blade, the steam velocity started to drop because of that increased pressure, as well as the steam pressure also reducing gradually from stage by stage. If you see the guided plate, the pressure is dropped off of the total pressure, steam pressure, and then again started to drop towards the exit of the rotor blade. This is the basic difference between impulsive turbine and reaction turbine. uh, Steam pressure and steam velocity. Reaction turbines is a type of steam turbine that works on the principle that the rotor spins, as the name suggests, from a reaction force rather than an impact or impulse force. In a reaction turbine, there are no nozzles to direct the steam like in the impulse turbine. The fixed blades, which are the same shape as the moving blades are mounted to the outer casing where the rotor revolves and are set to guide the steam into the moving blades. First one, the left hand side is showing that guided plate, and right hand side is represented that rotor blade. Here the number 1 represented that the steam enters through the section of curved plate in a fixed position. The number 2 represented that the steam then enter the set of moving blades and creates enough reactive force to the rotating shaft. Third one, which is the exit of steam. The steam exit the section of rotating blades. Fourth one, the direction of the rotation. The rotation will be come towards in that direction. This is that turbine schematic diagrams. We can see the fixed blades located on the top of the turbine blades, and then rotating blades located at middle of the blades, and then shaft is connected by bearings. The bearing also positioned at the turbine. The reaction turbine introduction. Gradual pressure drop takes place continuously over the fixed and moving blades. Already we have discussed this point in the previous slide. Fixed blades alter the direction of steam as well as allow it expand to a large velocity. As the steam passes over the moving blades, its kinetic energy is absorbed by them. The changes in pressure and velocity are also shown. As the volume of steam increase at lower pressures, diameter of the turbine must increase after each group of blade rings. Since pressure drop per stage is small, the number of stages required is much higher than an impulse turbine of the same capacity. This is reaction turbine schematic diagram. This is the cross-sectional view of a reaction turbine, which in see the casing, boiler steam entering and exit, and the soft position, steam exit. Here you can see the F and M notation, nothing but moving blade represented that M, fixed blades represented as F. Boiler pressure initially higher when the initial steam velocity low. At during the steam entering through the turbine blades, the boiler pressure started to reduce stage by stage. Finally, the initial steam velocity will increase when the boiler pressure dropped down. In order to reduce the velocity leads to lost velocity, and the condenser pressure also will provide that boiler pressure reduction values, and the supplied steam is entering into that fixed blade, which means that guide plate. Then the guide plate guide to pass the steam to the moving blade. Once entered that steam into the moving blade entrance, and then it is moving towards the exit of the moving blades. Finally it will enter that second fixed blade. In that cycle will be continuing till the final moving blade. Finally the steam exit through the steam out pipe. Thanks for watching this video. We will continue in that next video.